Hello students, here is a Canvas exercise set for weeks 11 and 12. First problem, you can stop the playback and read through. According to a report published by Gallup Institute on February 20, 2020, based on the interview that took place between February the 3rd and February the 16th, 65% of 1,028 randomly selected American adults responded that they were not too worried about someone in their family would be exposed to coronavirus. Does this survey suggest that the proportion of American adults that were not too worried or not worried at all exceeded 62%? By the way, where did the 62% come from? It came from the response from SARS outbreak in 2003. So 62% is not really arbitrary. Okay, all right. Let's set up the hypothesis and test it with the significance level of 0.05 or 5%. Now we have to set up the hypothesis, null hypothesis and alternative hypothesis. Null is always something to equal to, well, whatever number. So what is the expected proportion here? Hint, you have to select a number that did not come from the sample. You see, the proportion that came from the sample is going to be X bar or P bar. And that's something you're going to be using in the hypothesis testing, but it's not a part of any of the hypotheses. You have to select a proportion that did not come from the sample. Now, how many proportions do we have? We have 65% and 62%. Which one came from sample and which one was just given to you? This one was just given, and it is based upon previous year, or as a matter of fact, it came from 2003 figure. Now this one came from sample, 65% of 1,028. So the hypotheses are all revolving around 62%. Make sense? So here we go. The true proportion is about 62%. That's null hypothesis. An alternative hypothesis, well, you have to set up. Well, let's see. The problem said exceed 62%, so yes, exceeding. Or another way to see it, 65% is greater, so it must be pointing greater. That's another way to see it. By the way, here, I kind of play the role of purist, using pi as parameter for population proportion. Pi corresponds to P and is a Greek letter, but a lot of students will get a little bit confused here because pi in math course usually means something else. So let's go back to a little bit more usual symbol. Let's go to mu. Mu for mean. Okay, let's go back to that. If you're comfortable with pi, go ahead, that's fine. But I figure many of the other students won't. Okay. We set up the hypotheses and let's test it. Method number one is critical value method. That is, I'm going to get a normal picture around null, 0.62, and then I'll find out where the threshold is, and then compare that with 65%. Threshold is the critical value. Sample statistics, okay, here we go. Proportion is given as 62%, and then SC formula for proportion, you got to remember this. So here we go. Plug in 62% and 1 minus 62, or 0.62, 1 minus 0.62, and then sample size. Square root, this is what we get from standard error. Make sense? Run your calculator. And then the sample proportion turned out to be 65%, 0.65, and that's something you'll compare at the very end. Okay, all right. Now let's get the picture, and the outline will be given to you. I'll provide outline, but as for labeling the center and end and the shading correctly, those are all up to you. Here we go. Outline, we have this kind of normal picture, and center, it's always null, 62% or 0.62. and then I want something bigger. Okay, here's a critical value that I want to find out. And then too far away, then it's likely that null is wrong, so alternative wins. And close enough to null, then here H0 will win. Now, what's the threshold here? What's the critical value? Find out, and let's compare this with the observed proportion of 65%. If 65% comes here, then, oh, too far away, alternative wins. 65% comes here in the blue region, then, okay, it's close enough to null, so null wins. That's the idea. The picture is extremely important and it's required component. In the exam, I'll provide you with the outline, and everybody is expected to get the center, end, and shading appropriately. Okay, let's do critical value computation. Remember, end minus center over SE, that's about it. End minus center, 0.62, and then SE, we calculated it. And then that should be z-score associated to 5%. And let's see, 1.645, let me see, is that it? Here's a z-table. And then 5%. Okay, here we go, I found it. 0.0505 versus 0.0495. It's a push, so negative 1.64 or negative 1.65, it's got to be somewhere in between. That's why I got 1.645. And of course, I want something bigger, so instead of negative, I change it to positive. And all comes from the picture, and by now everybody should be already comfortable with all those. So here we go. We have this equation to solve. Flip this denominator over to the other side by multiplying, and which is, okay, maybe I skipped a step. X minus 0.62 is approximately equal to 1.645, positive of that, times the square root. Okay, we got that, and then flip this to the other side as well, and that's what this is. Run your calculator, and this is what you're going to get. Stop the playback and run your calculator. See how that goes. So, about 64% something, 0.64 something is the threshold. That's the critical value. How about 65%? It's slightly bigger than that. So if you draw a picture, null is 62% and 0.64 something, that is the critical value, and then 0.65 falls to the red region, alternative region. Too far away from the null, so HA wins. Make sense? Okay. This is the method I prefer the most. And then usually students score the best if they follow this kind of method because it's relatively easy to understand. Draw the normal picture around the center, the mean, the null, and then find out the critical value. And x bar is given, the observed proportion. So whether it's too far away or close enough to null is geometrically pretty clear. But there are some students who do not like this method. Then you can choose another method called p-value method, probability value method. It goes kind of like this. Same sample statistics, center and standard error, same formula. And here's the initial picture. Outline, center, and shade, but end is a little bit different. You get observed proportion here. And then find out the z-score with this, n minus center over SC, and then based upon that z-score, I can find out this probability P from the z-table. And then here's the hard part. If this probability value is greater than 0.05, then what? Less than 0.05, then what? There's something to think about. It's a little bit difficult to get to all those unless you have really solid understanding. And our textbook does okay job explaining this for the student who are already advanced and then understand the concept of type 1 error versus type 2 error, which is basically a conditional probability. The conditional probability, given that null is right, it's being cast out. But then again, it's really difficult to figure out this conditional probability. And that's why the students who usually go for this method don't do very well. At least that's my observation. They can do computation pretty much straightforward fashion up to here, and then what? Now there's a big jump from here to getting the conclusion. Well, let me give you a little bit of help. This p-value, probability value, is roughly speaking the probability that null is right. Okay, alright, it's really roughly speaking. It's not correct, but roughly speaking, it kind of corresponds to that. The probability that null is right. So if the probability is big, then null wins. If this is small, null loses. How big is big enough? How small is too small? That's the significance level of 0.05, 5%. So, find out the probability, n minus center over SC, calculate the z-score, run your calculator, and then this is what you get. 0.98 something. Okay, go to z-table and look up 0.98. 1.98, excuse me. And then 1.98 is here, 0.9761, and to the right, so 1 minus 9761, you're gonna get 0.023 something. So less than 5%, so null wins. Well, up to getting the picture and then getting the z-score and then getting the probability, no problem. And from here, how do we get the conclusion? That's where a lot of students stumble. Really a lot of students who choose this method. And that is why our textbook explains this probability value method first and make it a default. Me, I'm changing the order. I'm explaining this critical value method first. Because in my experience, students perform better this way than that way. I'm going to talk about hybrid method now, and this is a little bit related to critical value and probability method, both of them. Here's the initial picture, and then instead of drawing this along the null, making it to standard normal and then bring it to 0, and then get z-score, the threshold z-score, the critical z-score. Critical z-score, of course, associated to the 5%, yeah, 0.05. Yes, as we calculated already, it's 1.645. And then compare that with C bar, and then same familiar question. Now what? The C bar is greater than that. What does that mean by that? And that's where a lot of students stumble. It's kind of like this. This one, bigger means going too far away and going into this red region, and null wins. That's the idea. But then again, these numbers are kind of scaled numbers, so it's a little bit difficult to understand. And that's why, again, students choosing this method do not perform as well. And that's why I emphasize the first method, critical value method, before anything else. That is my suggestion, but in any case, it'll work if you do it right. Okay, so much for problem number 1, and let's meet again in separate video for problem number 2, 3, and 4.